Dear students, hello. I would like to proceed with our lectures on the topic of tension processes, and in the previous part of these lectures I have explained you how to deal with when we have a case of connection of connection of sorry, of connection of uh, AC source to RL circuit. At first it was connection of DC source on the same circuit, and then we consider case when AC source is connected to RL circuit. And we consider in previous lecture that tension current through such circuit may be presented in such a form as a sum of forced component, which has sinusoidal form because forced component depend on the shape of connected EMF, and it will consist of tension processes which is just the same as in the previous case of connection the RL circuit to a DC source. Then let's determine integration constant A for such a case. For this we will use, as in previous case, we will use first switching law, which tells us that current through inductance before commutation at the moment -0 should be equal to current through inductance at the moment just after commutation. It's depicted here as IL from 0 plus. So we do know that for such a problem, this source is disconnected from IL circuit, so IL was equal to 0 and UL was equal to 0 for the moments for all time period just before commutation. So we can write down that IL from -0 equal to 0. Then let's write down IL from 0 plus. It will correspond to this expression when t time equal to 0, and it will be I maximum sinus psi minus phi for this item, and for this item it will be just A, as I explained many times before. So we have this expression for IL from 0 plus, and it's equal to 0 because IL from -0 equal to 0. And from here we can determine this integration constant from this equation. It is here. Then we should substitute this integration constant into the expression for current through inductance. It is here. It will be a forced component and it will be natural component with minus, you see. And this, please regard that this coefficient does not depend on time. No time is here because we substitute in this expression for obtaining this coefficient. We substitute t equal to 0. So we have such expression. From here we can determine voltage drop across inductance, and it will also consist of two components. In previous case, forced component was equal to 0 because voltage drop across inductance in steady state DC process equal to 0. Inductance behaves like a short-circuited part of schematic in DC steady state processes, but for connection to AC source, voltage drop across inductance will not be equal to 0, as you know from course of the previous semester. How can we determine UR? It will be, for this we should take derivative from IL, or we can just write down UL first, yes, as product of UL maximum and sinus omega t plus psi UL. And we do know from previous semester that maximum level of voltage drop across inductance equal to maximum level of current through inductance multiplied by module of complex impedance of inductance is equal to omega L. So UL maximum will be equal to omega Li maximum. This coefficient. And we do know, you should remember from previous course that voltage drop leads current through inductance, voltage drop across inductance leads current through inductance by 90 degrees, because we can write down that UL phasor equal to J omega L I max I phasor. Yes, so it is 90 degree, its initial phase will be 90 degree bigger than initial phase of current. So we can write down that psi UL equal to psi IL plus 90 degrees, or as psi IL equal to psi E minus phi, we write it down, and plus 90 degrees. So we can write down that natural component, it's easier to determine it as derivative by time from natural component of current through inductance multiplied by L, level of inductance. So we should take derivative from this item which correspond to natural component of current through inductance. You see, this is just constant coefficient which does not depend on time, no time here, you see. So it will be written just before this derivative, and then it should be multiplied by derivative from exponent equal just to exponent, and it should be multiplied by derivative of this argument. It will be equal to minus R over L. So we write it down, you see, L, then di maximum sinus psi E minus phi, because it is coefficient which doesn't depend on time, multiplied by this exponential function and multiplied by minus R over L. Then we cancel a common coefficient. You see, this L and L will be cancelled, and we will have minus and minus will give us plus, and we will have here R multiplied by I maximum, yes, multiplied by sinus psi E minus phi, and multiplied by this exponential function. It is here. So we can write down that UL equal to sum of first component, which is determined here, yes, substituting here this expression for UL maximum and psi UL, it is here, and plus this natural component which we got by differentiation of natural component of current through inductance. So we've got this expression. As IL here, this 9 expression, and UL, this expression, include psi E. You see, here is psi E, and here is psi E, here is psi E. You see, in transient component. So transient processes and all current and voltage drops through inductance will depend on the moment of connection, on the phase, initial phase of AC source, moment when initial phase is defined level, and so it will depend just on the moment of connection. Maybe you have been noticed that as a rule our plain lamps have been broken just at the moment of connection, whether you turn off or turn on light, and it is just due to dependence of transient processes which occurs at switching on or switching off these lamps depends on the moment of initial phase of the source. So let's consider two extreme cases. First, it's when initial phase of electromagnetic force of this EMF of this source, when it's, you see, when its initial phase psi of this source just equal to phi. Phi is determined only by parameters of RL branch, and it's equal to phi equal to a tangents of omega L to over R. You see, it will depend, of course, on the frequency, but now we consider only power frequency 50 Hertz. So when psi equal to phi, then you see, if they are equal to each other, then initial phase of this sinusoidal function will be equal to 0, and sinus of 0 equal to 0, and therefore it will not be any transient processes in such a case. So in such a case, this transient component will vanish, and we will have, you see, because this integration constant equal to directly proportional to sinus of psi minus phi will be equal just to 0. So it will not be any transient processes. And in such a case, current through inductance will be just I maximum sinus omega t. Okay, because we have this expression: if psi minus phi equal to 0, these two items will vanish, and we will have only sinus omega t, like here. The same refers to UL. It will be omega L I maximum sinus omega t plus 90 degrees, because voltage drop across inductance leads current through inductance by 90 degrees. And graphs of currents and voltages will have such a form. You see, for current, it will be just sinusoidal function starting from 0, okay, only first component. And for voltage drop across inductance, it will be cosine function. Why? Because sinus omega t plus 90 degree equal to cosine omega t. You see? So it will be, it will lead, I mean UL will lead IL by 90 degrees, because we have here plus 90 degrees. So it's the most favorable case when we have not any transient processes at all. It's first extreme case, the best, and then let's consider next case. We may consider it, as the worst case, when difference between initial phase of applied AC EMF and this phi, which depends on properties of RL circuit, is equal to plus minus 90 degrees. So we have this shift between these angles, firstly equal to 0, and secondly equal to its maximum level, to 90 degrees. You see, and in this case we will have the worst case, when we will have the maximum level of natural component, because here we have you see, we have for instance, for this integration constant, if psi minus phi equal 90 degree, sinus of 90 degree will be equal to 1, to unit its maximum level of sinus. So A will have maximum level, and therefore natural component will have maximum level also. And we can write down that A equal to minus I. Let's assign that psi equal to phi minus 90 degree, it doesn't matter, minus or plus, let's consider this case of minus 90 degree, we will have A equal to minus I maximum sinus psi e minus phi, it is 1, so we have minus just minus I minus 90 degree, it will be plus I maximum. So we can write down that IL equal to I maximum sinus. It will be, you see, instead of this psi e minus phi, we will substitute minus 90 degrees, okay, sorry, here minus 90 degrees, so it will be forced component, and natural component will be with sinus equal to 1. So we have such an expression for current and corresponding equation for voltage drop. So let's proceed in the next part of lecture. Please listen attentively this part, because it was not read in the beginning of this semester before the war has started. So please listen it, and please comprehend the material. If you have any question, don't hesitate to ask me via Office 365 email. You do know my email, please ask me and I will answer your questions. Maybe maybe I will write something to you, try to answer a question, or we may, if there will be many questions of the same time, I may try to ask you in the same way via YouTube, and I think that it will be nice. So bye bye for now, for the next part of these lectures.